we will see few exercise problems. Some of them we would have discussed earlier itself. Now here we find the diameter conjugate to given diameter in the case of ellipse as well as in the case of hyperbola. That's the first question. So first we rewrite the given ellipse equation in this way, in the standard form, and in the same way the equation of hyperbola is also rewritten. Now we consider this diameter, that's rewritten as y is equal to 1 by 4 into x. Now our job is to find the diameter which is conjugate to this diameter. So suppose I assume the required diameter to be, say, y is equal to mx, then when I consider this, that is ellipse, then in that case we have to have our condition to be m into 1 by 4 to be equal to minus b square by a square. So that means we have 1 by 4, this 4 and this 4 will get cancelled, giving m is equal to minus 1. So for this, conjugate diameter will be y is equal to minus x. And as for this is concerned, you have the procedure to be the same, m into 1 by 4, but here with the plus sign. So you have 9 by 36 simply. So cancelling this 4, m equal to 1. So in the case of hyperbola, we have the diameter which is conjugate to the given one to be y is equal to x. And likewise you have these problems. You have y is equal to x, y is equal to minus x, y is equal to 2x. For all these diameters with respect to ellipse as well as with respect to hyperbola, we can write out the equation of the conjugate diameters. Now the next one, define conjugate diameters of an ellipse of a hyperbola. So these questions can be asked in section A, and also write in the condition for two diameters of an ellipse to be conjugate diameters. We have m1, m2, the product of their slopes, to be minus b square by a square, and for this it is m1, m2 is equal to b square by a square. So it should be started like this. If the two diameters are of the lines with slopes m1 and m2, then like that it should be written. And in section we have one more, find the equation of the hyperbola conjugate to the given one. See, for this we have to make use of this formula c is equal to 2a minus h. That is, from c minus a is equal to a minus h, we can obtain this. So if I am given hyperbola, then we know how to find the equation of asymptote. If we assume the equation of asymptote to be like this, plus c, the same thing, because asymptote and hyperbola, they differ by a constant. So accepting the constant, the rest of the terms are written, plus c we have. We need to determine what that c is, assuming that this represents a pair of straight lines. So that means this AHG, determinant AHG, HBF, GFC equal to 0 should be used. So in this case, A stands for this, H is 13 by 2, and then AH, this is AX square plus 2HXY plus BY square. So your B will be 3. 2GX, so 2G is 1, therefore G is half. And this is F, 3 by 2 is your F, and C remains as such. So when you expand this out, you will get what that C is, and that will give the equation of asymptote. You know the equation of conjugate, hyperbola, you know the equation of asymptote from here. Make use of this, C is equal to 2a minus h, so that C is equal to 0 gives me the equation of the conjugate hyperbola. Now in section B, these questions can be expected. Prove that the sum of the squares of two conjugate semi-diameters of an ellipse is constant. In the case of hyperbola, it is difference. The sum is only for ellipse, but for this it is difference. because we proved that CP square minus CD square is constant in the case of hyperbola. In the case of ellipse only, it is CP square plus CD square is constant. So these are all bookworks, rather theorems. Now prove that the eccentric angle, it's one of the properties of conjugate diameters in the case of an ellipse. Prove that the eccentric angles at the ends of a pair of conjugate diameters differ by a right angle. And next is find the equation of equi-conjugate diameters of the ellipse. This is also a bookwork. You have in the case of equi-conjugate diameters of ellipse as well as hyperbola, the procedure is the same. Equi-conjugate means you will have the length to be the same. So from which tan theta you will get it as plus or minus 1. So from that we can easily obtain the equation of equi-conjugate diameter that's discussed earlier in one of the videos. And the next one is show that the polar of any point on an asymptote of the hyperbola is equal to 8 with respect to the hyperbola is parallel to that asymptote. So for the general case, x square by a square minus y square by b square equal to 1 we have established. So it is again the same concept that is to be used to prove this fourth one. Now the fifth one is find the equation to the asymptotes of. We are given the equation of hyperbola. Hyperbola and asymptote differ by a constant. So we will have to have this to be your asymptote, which is to be determined using AG, HBF, GFC equal to 0. Here A is 2, B is 0, H is 1, G is minus 3 by 2, F is half, and C remains as such. So substituting these values over here, you will get what that C is. So that will give the equation of asymptotes. And in the same way for the second one also. Now coming to section C questions, if P and D are the extremities of conjugate diameters, show that the locus of midpoints of PD. See, we know the coordinates of P, that's A cos theta, B sin theta. This is minus A sin theta, B cos theta. So your x1 will be A by 2 because midpoint, you know. So sum of those two divided by 2. So the coordinates, இதனுடைய coordinate வந்து A cos theta, B sin theta. இதனுடைய coordinate minus A sin theta, B cos theta. So நம்ம midpoint எப்படி கண்டுபிடிப்போம்? You have to add the first coordinate ரெண்டுத்தையும் add பண்ணி you have to divide it by 2. So that's what is done here, and in the same way for the next one. So இதிலேருந்து என்ன கிடைக்கும்னா x1 by A எனக்கு கிடைக்கும், y1 by B எனக்கு கிடைக்கும், and then if I square and add we will get the equation to be like this: x1 square by A square plus y1 square by B square equal to half. So we want only the locus of the midpoints, so dropping the suffix you get this. And in the same way tangents. So write down the tangents at P and D. Take the point of intersection as T of x1 y1 and substitute that x1 y1 in both the equation, that is the equation of the tangent at P as well as at D. And then squaring and adding, you will get a relation of this form: x1 square by A square plus y1 square by B square equal to 2. And by dropping the suffix you get the locus. Then this one is also proved that the tangents at the ends of a pair of conjugate diameters of an ellipse form a parallelogram of constant area. So the question is to be read carefully, because is it asked for an ellipse or is it asked for a hyperbola? That should be very clear. And so in the same problem we are asked to show that they prove that the parallelogram formed by the tangent at the ends of conjugate diameters has its vertices. So the tangents, they intersect on the at a point on the asymptote, and then you have to show that. So that's a theorem that we have already established, actually one of the properties. If a diameter meets a hyperbola in real points, then the conjugate diameter meets the hyperbola in imaginary points and the conjugate hyperbola in real points. So that is also done earlier. And here comes a problem in which you will have to determine your asymptotes. A hyperbola, as for its asymptotes is given. You will have to find out the hyperbola. So far we have been given the hyperbola. We tried to find the asymptotes. So here asymptotes equation is given. You will have to find out, a hyperbola as for its asymptotes, the straight line. So asymptotes given, you will have to find out what is the hyperbola. You are also given to determine that on condition that it passes through the point 1, 1. Right, now hyperbola and its asymptotes differ by a constant, so we make use of that, and because it passes through 1, 1, substituting the values we get k to be 6. So the hyperbola, as it's for asymptotes this, and it passes through, so find its equation means having got k value, just substitute, so this will give the combined equation. Now find the equation to the hyperbola which passes through the point 2, 3 and has for its asymptotes the lines. So we have to consider this 4x plus 3y minus 7 into x minus 2y minus 1, and so the equate to 0 will give the asymptotes, but we want to have the equation of hyperbola, so equate it to k and substitute in the place of x 2, in the place of y 3. So that would give the unknown, and that's how we find the equation of the hyperbola which passes through 2, 3 and has for its asymptotes the lines. Asymptotes கொடுத்துருக்காங்க, அந்த செப்பரேட் ஈக்குவேஷனாக இருக்குது, அதை மல்டிப்ளை பண்ணி கேக்கு ஈக்குவேட் பண்ணிங்கன்னா கேவை கண்டுபிடிக்கணும். இப்போ கே கண்டுபிடிக்கிறதுக்கு உங்களுக்கு ஒரு கண்டிஷன் கொடுத்துருக்காங்க. ஸோ தட் இஸ் யுவர் hyperbola passes through 2, 3. இதுதான் அந்த ஹிண்ட். அந்த கே கண்டுபிடிக்கிறதுக்கு எதான ஒரு ஹிண்ட் கொடுக்கணும். ஸோ that hint is it passes through 2, 3. அடுத்தது find the equation to the hyperbola which has for asymptotes. So again the same procedure. We'll have to equate that to k, determine what that k is, and so that will give the equation of hyperbola. Then center of the hyperbola and the asymptotes, the point of intersection must be the same. So when we solve it, we get it as minus 1, 1. So coordinates of its center is minus 1, 1, and the rest are already established.